It is a strong acid. Why it is strong acid? Because it 100% ionize. For example, this is an acid and this is the hydrogen ion. If I take, for example, 100 like this, all the 100 will break, all 100, and I will get 100 hydrogen ion on the other side. This breaking is called ionization. So if there is 100% ionization, that is called a strong acid. If I take acetic acid or ethanoic acid, if I take 100, maybe only 15 or 20 will break. 15 or 20 will break to give the hydrogen ion. The remaining 80 will not break. So, not 100% ionization. That is called a weak acid. Weak acid. Acetic acid is a weak acid. Hydrochloric acid is a strong acid. Because it is a strong, it goes to this side. Because it is a weak, it also go back. Reversible. Did you understand?
Yes.
This is called an acid. Acid is a substance which gives hydrogen ion in water. So simple definition. Opposite of the acid is called base. Base is a substance which accept hydrogen ion. Acid give hydrogen ion, base accept hydrogen ion. It is opposite.
Yes.
There are certain base which can dissolve in water, and there are many which do not dissolve in water. Those base which can dissolve in water, they are called alkalis. And the alkalis, they can give OH ion, OH hydroxide ion in water. They can also accept proton, but the alkali now has another definition. They can give the OH ion in water. Alkalis are two types: strong alkali and the weak alkali. If we have a strong alkali, sodium hydroxide, 100% ionization. It gives the OH ion. Look over here. It gives the OH ion. If this is an alkali, this is the OH ion, it will break all. If I take 100 of this one, all the 100 break and give the OH ion, it is a strong alkali. And the weak alkali, like ammonium hydroxide, it will break only 10%, 15%, 20%. We have 100, but I get only 20 of the OH ion. And the reaction goes back, reverse. And the strong one, only one side. Did you understand?
Yes.
So, I will show you the test of these acids and base with the indicator, and you will see that the indicator, they will tell me this is acid, this is base. But the indicator will not tell me which is strong and which is weak.
Because between particles, so you can, the color,
Yeah.
does the color tell us is it?
Yeah, color change will come. I will show you now.
200.
There will be a color change, but the color change of the strong and the weak will be very close. Very difficult to identify them. Then I will do the same experiment with the pH meter, and it will tell us exactly which is strong, which is weak. Okay? And I will tell you so many other things about the pH meter. So that is what the experiment is today. Now, there are so many indicators, dozens of indicators. I have selected two indicators for the sake of simplicity: phenolphthalein and methyl orange. You will go to the other classes, you will study a lot of indicators. Okay? I take HCl. What is HCl? Hydrochloric acid. Is it strong? Is it a strong? No, it is a strong one. So, I take hydrochloric acid and I take acetic acid. Acetic acid is a weak one. The other name is ethanoic acid. Here is the phenolphthalein, which is colorless. When I put a drop or two drop over here, one or two drop over here, you see that no change. No change. The same color.
Why?
The same color because phenolphthalein in acid does not change the color.
And base change.
It base change. So it is over here. Now I take the other tubes. I again take HCl. It is a strong one.
That's a lot.
And I take ethanoic acid. I take ethanoic acid and I add into it the indicator. When I add in 1 or 2 drops, 2 drops, 2 drops, and
acid weak.
yeah, I'm sorry, I should have taken this one. I'm sorry for that. Yeah, I did this one. I showed this one. Let me take it again. And here I have the weak one.
Doctor,
Yes.
is it okay if I touch the HCl?
It is too much diluted. No problem. It is. I have added too much water in that. Okay. So that's why it's no problem. Because when you are dealing with these things, I have made them very soft. See this one. So the color changed to pink and the color changed to pink. Look, there is not much difference. Almost same. This is a strong, this is a weak, but almost same. You see this one?
Yeah.
Because the indicator is telling me this is an acid, but it is not telling me which is strong, which is weak. If I take like the base, and you know that sodium hydroxide, is it strong or weak?
Strong.
Yes, it is a strong one. So it is a strong base because it 100% ionized. And I take ammonium hydroxide and I put into it phenolphthalein. I put 1 drop here, 1 or 2 drop, and 1 or 2 drop here, and then I shake it,
Purple.
and both of them are same color. One is strong, one is weak, but I get the same color. Alright? I repeat this test. I repeat this test with the other indicator. Again I take. Now I take.
ما قلت كده.
Here is the other one. And now I take methyl orange. I put 1 or 2 drops, 1 or 2 drops, and you can see that it changed to yellow. If for example the methyl orange changed something to yellow, it means it's a base. So if for example I have no label, if these labels are removed and I do the test with that, it will tell me this is acid and this is a base. But what it will not tell me? It will not tell me it is strong. Did you understand this point?
Yes.
Okay. So this is what the indicator they do. Now I am coming to the interesting part about the pH meter. This is the first instrument in your life, scientific instrument, which you are going to use it. And when you will go to the other class, you use the other instrument, mass spectrophotometer, then spectrometry, NMR, gas spect, so many, and all of them very interesting, and you will like them all. This is called pH meter. The pH meter, it measures the hydrogen ion. It measures the hydrogen ion, and if hydrogen ions are known in any solution, all the water, for example water, it breaks into hydrogen ion and hydroxide ion. So any solution, listen carefully, any solution which is made in water will have hydrogen ion. So it measures the hydrogen ion and if we know the concentration of the hydrogen ion, we can find the pH. So
Minus.
minus log of hydrogen ion. So you can find, for example, I tell you last time we did the experiment of molarity, standardization of the base. Do you remember?
Yes.
That was molarity. and we find the molarity. If I know that the molarity is, for example, 0.5, I will put 0.5 here, and from the calculator I take minus log, and I will get the pH. The same thing the computer will do. The computer will do, it will find in the solution how many hydrogen ions are there, and there is a calculator, immediately it will change into pH. pH is an alternate scale. It is another scale which tell us about the strength of an acid and a base. Last time we did molarity. From the molarity we can tell that 1 molar is stronger than half molar. The molarity. Molarity is a unit of concentration. Normality, percentage, molality, these are the other units. Similarly, pH is a scale similar like molarity. I give you an example. In your car, on the speedometer, you have kilometers per hour. If you want to change it into miles per hour, you can do it. Same thing. You can say 120 km per hour mean 80 miles per hour. If you know the temperature in Celsius, you can convert it into Kelvin. Same thing, equal, same thing, but the scale is different, right?
Yes.
So if we know the molarity, we can find the pH. If we know the pH, we can find the molarity. So it is the same thing converted to other, and it tells us the strength of an acid and a base. It goes from 1 to 40. 7 is the neutral point. Water. If I am going to the extreme end, to this side, 1 to 2,
Strong acid.
it's a strong acid, like HCl, like sulfuric acid, like nitric acid. And if it is coming in the middle here, it's a weak acid, like acetic acid, like carbonic acid. In the Pepsi 7-Up, you have the carbonic acid because it's the weak one, that's why you can drink it. So that will come over here. If we have an alkali, which is a strong alkali, it will go to the other extreme, this extreme, 12 to 14, like sodium hydroxide. If we have a weak alkali, so it will come over here in that range. Okay? So we are going to, yes, any question, boys?
The alkene.
Yes, any question?
Alkene is basis.
Alkali is a base. I told you, listen once again. Base is one thing which donate hydrogen ion. This acid is one thing which donate hydrogen ion, and base is a thing which accept hydrogen ion.
So
And if some base dissolve in water, it is called an alkali. If some base dissolve in water, this is called alkali. So all alkalis are base. All alkalis, they are base. But all the base, they do not dissolve in water. Did you understand?
Yes.
And now the alkali has two important things. One thing, because it is a base, it can accept the proton. One thing more alkali can do, it can give the OH ion. The alkalis, they can give the OH ion. But if it is not soluble in water, then it will only accept the hydrogen ion, it will not give the OH ion. That is the difference. Did you understand?
Yes.
Alright. This is the pH meter, and this is a scientific instrument. Whenever we use any scientific instrument, the first thing we do to calibrate it, to standardize it, to make it accurate. I give you an example. If, for example, you have a balance means mizan.
Yeah.
You have one box, you know this is exactly 10 kilogram. You take it, put it on the balance, and the balance tell you it is 9.5, not 10. So what you do, you adjust the balance, you calibrate it, you make it 10. Once it is calibrated, now you take another box which is exactly 20. Take it and put over there, it will tell you 20. If you take another which is exactly 5, put over there, it is 5. Because now it is calibrated. Similarly, when you use any of the scientific instrument, the first thing you do is to do the calibration. Once it is calibrated, we can use anything. It will tell you the right, correct reading. Did you understand?
Yes.
For the pH meter, we calibrate it with a buffer solution. Buffer. Anybody knows what is buffer?
No.
No. A buffer solution is that. Boys, can you see me from the back? You can see me that? Yeah, it's very interesting. And why it is interesting? Because you all are going to study the buffer a lot, not 1 year, many years. From now to onward, in the medicine or in the other college, you are going to study buffer a lot, too much. So that's why take some interest in that. Buffer solution is the one which can maintain its pH at a level. Do not change. Now I give you an example. For example, here is the pure water, distilled water. What is the pH?
7.
Its pH is 7. Here, its pH is 7. If I add only 1 drop acid, 1 drop HCl, it will go from 7 to 2 or 3. So big change. And if I put only 1 drop base, sodium hydroxide, it will go 12 or 13. But in the buffer solution, if I put so many drop of acid,
It will keep
so many drop of base, its pH will not change. So this is called the buffer solution. Okay? Did you understand? What is the
Yes.
buffer?
Yes.
So buffer, they are extremely important things. Extremely important. I give you two, three examples. You will understand the importance of the buffer. For example, our blood has a buffer system, hydrogen carbonate buffer system. Now the pH of the blood is 7.35. That is the pH of the blood. Now in our daily life, we are taking so many acids, so many base. We take citrus fruit, lemon, grapes, Pepsi, acid thing and base thing, but the pH remains 7.35, never change, because it is a buffer. The blood, did you understand?
Yes.
Because it is a buffer, so the pH is not changing. If there is a change in the pH, even little change, we become sick sometime. And if there is a little change, it will cause a big problem. For example, if the pH become 7.4, what is the actual pH? 7.35. Little change, it becomes 7.4. It will make a very strong bond with the oxygen. So strong, when the blood will go to the tissue, it will not give oxygen to the tissue. The bond of the hemoglobin is very strong. And if, for example, its pH becomes 7.3, from 7.35 to 7.330, it will not make a bond with the oxygen. It will go to the hemoglobin will go to the lungs, but it will not take oxygen. So buffers are very, very important. Do you understand?
Yes.
I give you one more example. Did you know the acid rain? From the industries and from
Yes,
cars,
yes.
the gases go, acidic gas, sulfur dioxide,
Yes.
nitrogen dioxide, in the clouds, and then the cloud, this is called acid rain.
With the dust.
Yes, the acid rain. What the acid rain is doing on the soil?
Destroy all. Dissolve it.
It will not let the plant to grow, right? But in the soil, Allah has put a buffer system in the soil. What happened? The acid rain is there. After 2 weeks, again the plant they grow. Because of the buffer. Because of the buffer. The buffer, the soil do not change. There is acid. It do not change its pH. Right? So in that way, of course, I can see you are taking, mashallah, a lot of interest. Definitely many students have a lot of questions. How the buffer is made, what is a buffer, what is that special thing. There are so many things. It's a very interesting topic, but since this will be out of my subject of experiment. So that's why I'm not going in detail. Otherwise, it is a very interesting topic. If sometime we are free, we can discuss a lot about the buffer.
The spelling.
Buffer spelling B-U-F-F-E-R. Okay, boys? So, now listen to me. This instrument, this pH, as I told you, that if I have a box, I put on the balance and I have to calibrate it. Similarly, when I am going to use this one, I have to calibrate it, and I am calibrating it with the buffer solution. This buffer I made pH 4. Okay, there are variety 4.1, 5, 6, 7, 8, 9, so many. But I made this buffer as pH 4. And in the pH meter, here is an electrode. Here is an electrode. Inside there is a platinum wire through which the current can pass. And there is a liquid. Can you see the liquid?
Yes.
This is called electrolyte. Electrolyte. Electrolyte is something through which electricity can pass because it is an ionic liquid. Electrolyte is an ionic liquid. Electricity can pass through that. And at the tip here, there is a bulb, glass bulb. And this glass bulb is very sensitive, very thin and very sensitive. So when I dip it in a solution, aqueous solution, it can detect how many hydrogens are there. It can detect the hydrogen ions. And I am washing it. Why I am washing it? So anything which is before should be removed. So if I put over here, I am cleaning it, and I put the buffer solution, and in the buffer solution, or if there is any solution, this is a buffer solution, the electrode, it will find how many hydrogen ions are there. Here it is, now it is finding the hydrogen ions. There is an exchange of the ions taking place from the tip, and as a result of that, listen carefully, very important sentence, as a result of that, a potential difference is created. You will study potential difference in physics. A potential difference is created. That potential difference, here is the calculator, it calculates directly into pH. So what the electrode is doing, it is looking for the hydrogen ion. The electrode is looking for the hydrogen ion. When it will find how many hydrogen ions are there, it has a calculator, it will change the hydrogen ion into minus log of hydrogen ion and pH will come over here.
How long is it going to take?
Just say finished. So it's 4.1, it's the same which is there. So now it is the meter, now the meter is ready. Like that balance is ready. When it was telling you 9.5, you made it correct. You told the balance, no, not 9.5, it is 10. Similarly, I told the meter what is the pH I am giving. So I told him that it is 4.1. Before you came, I did all the work over there. I told him, look, this is 4.1 and now it is telling me 4.1. It is telling me 4.1. It means that now it is ready to use for all these solutions. If I put any solution, it will give me the exact answer. Okay? Alright, now what I do, I take this one and I will wash to remove what I am removing now, the buffer. I am removing the buffer. The old thing which is here, I am removing it. And I will put into it a solution. For example, I will put HCl. What is HCl? Which acid? HCl is a strong acid. HCl is a strong acid. Yeah, it is a strong acid. Strong acid means where it should come? 1 to 2. It should come between 1 to 2, right? And look, it is giving you a reading me like 1.7. What does it mean?
Strong acid.
Strong acid. Did the indicator told me is it a strong acid?
No.
This indicator didn't tell me it is a strong acid. What the indicator told me?
They are.
He said it's an acid. He said it's an acid. The indicator only told me it's an acid, but it is telling me no, it is a strong acid. Now I take acetic acid, right? What should I do? Wash it. Very good. Why should I? Remind me, please. Why should I wash?
To remove the
Because of the acid. Acid is there.
Acid before.
All right. So I take this one and I put that. Why I am shaking? What is the purpose of shaking?
To make
To increase the exchange faster. Because what it is detecting? What it is detecting? The hydrogen ion.
Hydrogen
And
ion.
I am moving it little so that exchange could be faster. And the pH is 3.35. What does mean 3.35? It's a weak acid. It's a weak acid. So I put it over here. You just look into that. Later you can copy. If you have not copied, you can copy it later. Just look what I am doing. Now I take sodium hydroxide. What is sodium hydroxide?
Strong base.
It's a strong base. What should be the pH?
12 to 14.
12, between
Yeah.
12 and 14.
Yes, between 12 and 14. Between 12 and 14. And boys, it is over here. And I will give it some time to do this one. And this, what is the pH I am doing over here? It is very small part of this use of the. There are so many other uses for the pH meter. Today I am just giving you an introduction. Look what it is doing. Otherwise, you know, titration which we did last time.
Yes.
We also do titration with this one. We do the titration which is called potentiometric titration. So many things we do with the buffer. So many things. So what I am telling you that this is an introduction. What is the pH meter? How we work with that? So the pH is 12.35. 12.35 mean what?
strong.
Strong base. And now the next one is ammonium hydroxide, which is a weak one. And right, that's correct. To remove this one.
Doctor,
Yes.
do you push any button or just you put the glass and move?
I just put the glass. Because I have calibrated it. When I will use it next time tomorrow, again I will do the calibration. Because every day the calibration should be done. Every day.
When we are doing the experiment.
Yeah, when we are doing the experiment, we have to calibrate it. Because if we do not calibrate, maybe it will not give the correct result.
How can
And
how
the
can
with the buffer solution, and there are buttons.
but
And from the buttons we tell it. It's a good question. We tell this solution is a solution with a pH 4. So I have to tell it. It does not know. The buffer does not know it is 4. I tell it that look, now I am giving you 4. So it will recognize the 4. It will recognize the 4. Then I will tell you another one. Okay, this one is 7. It will recognize the 7. It means now it knows that.
we have to identify before.
Yes, that is called calibration. And once it said, it will say, yes, now I am ready. Now you bring anything, I will do that one. Then it means it is calibrated. So 8.7. 8.7 mean what? It's a weak. It's a weak base. Now the next part, few minutes are left. The next part is very interesting. Now, for example, and this will tell you about the salt. Do you know any salt?
Salt.
Sodium hydroxide is the base. What is the salt? Give the name of any salt. Sodium chloride. So many salts. Sodium chloride, potassium nitrate, calcium sulfate, calcium. So many salts. Hundreds salts are there. And some of the salt, they dissolve in water. And some salt, they do not dissolve. For example, look over here. For example, I have ammonium chloride, NH4Cl. You know the formula? Ammonium chloride, NH4Cl. I put ammonium chloride in water But what will happen? The water will break into two parts, hydrogen ion and OH ion. And the salt will break in two parts, ammonium and chloride. Ammonium will take OH and form ammonium hydroxide. This chlorine will take H and form HCl. It means that if I put ammonium chloride in water, I will get two things. This one, the base and the acid.
Weak base and strong.
Very good. Do you know ammonium hydroxide is a weak one?
Weak.
And HCl is a strong one?
Yeah.
If they are mixed together, the net effect, the result will be more than 7 or less than 7. HCl is strong. HCl is strong acid. And ammonium hydroxide is a weak acid base. Less than 7. So I take ammonium chloride. And I wash it. And I put into that, I shake it. It is ammonium chloride. And the answer comes 5.35. What does it mean?
Weak acid.
It is acidic. This salt is acidic salt. This salt is acidic salt because the pH is less than 7. Now listen. If I have another salt, listen boys. If I have another salt, sodium acetate, I dissolve it in water. The water will break and the salt will break. There is sodium, it will react with OH and it forms sodium hydroxide. And acetate will react with hydrogen to form acetic acid. Weak acid and strong base. More than 7. And let me see this one, whether it is coming more than 7 or not. Okay boys, listen, the answer comes to 9.6. What does it mean? Basic, it means it's a basic salt. Did you understand?